So far, we've learned how to set up neural networks and discuss their architecture. We've split our data into sets, but haven't really discussed that process in detail. Now it's time to focus on this critical aspect of model training, the division of your data into training, validation, and test sets. This step ensures that your neural network not only learns, but also generalizes effectively to new, unseen data and avoids underfitting. The first and perhaps most crucial dataset is the training set. This is the data the neural network learns from. During training, the network adjusts its internal parameters, weights and biases, on the basis of this data. The goal is to minimize error in the model's predictions by iteratively updating these parameters. Typically, you will allocate 60 to 80% of your dataset to the training set, depending on the overall size of your dataset and the complexity of your model. While more training data may improve a model's generalization, this must be balanced with the needs of the other sets. Overfitting occurs when a model learns the training data too well, including its noise and specific elements of it. This can lead to poor performance on new, unseen data. How do we tell whether our model is overfitting or is still genuinely improving its performance? This is where the validation set comes in. The validation set is used during the training process, but does not update the model's internal parameters. Instead, it checks whether the model is generalizing well. After each epoch, the model's performance on the validation set is evaluated. If the model is performing well on the training data, but poorly on the validation data, it might be overfitting, learning irrelevant noise rather than useful patterns. Typically, the validation set comprises of 10 to 20% of your overall dataset. The validation set helps us to tune our model with hyperparameters such as learning rate or the number of layers adjusted accordingly. The dataset for testing is independent of the training and validation processes and remains separate throughout development. After the model has been trained and its hyperparameters tuned, it's evaluated on the test set to provide an unbiased performance estimate. This step is kind of like a final exam, testing the quality of the model's predictions for new, previously unseen data. The test set should only be used once, after all training and validation has been completed, to ensure a true assessment of the model's generalization performance. Typically, the test set makes up the remaining 10 to 20% of the overall dataset. Deciding how much of the overall dataset to allocate to each purpose is a balancing act that depends on your specific data and goals. By carefully managing these individual datasets, you ensure that your model both learns effectively and performs well when faced with new data. This process is really important when building neural networks that are not just accurate, but truly useful in practical applications.